Welcome back, everybody. We're continuing our chapter on the basics of Java. Today in 1.2, we're talking about variables. Let's rock and roll. All right, so first thing, what is a variable? I'm going to say that a variable is a storage location for a specified type of value. Okay, so why do I need variables? Well, pretty much any program I can think of, you want to store some information and use it later. Okay, probably the easiest way to do that is just with variables. So what I have here are a few lines of code that would make and assign variables. And also a very simplified version or model of what's happening in the Java memory. Okay, but each of these lines will create a variable. Let's walk you through what's happening there. We'll go through more detail in a few minutes. The first thing I need to do in Java is I need to specify what type of variable I want to store. Okay, an int is a type, a double is a type, a boolean is a type. Basically, I need to tell Java how much space to give this variable, how much space is going to need to store it. Okay, so let's say we are making an int. I'm going to give it a name. Let's say that int is num as a number, and then I'm going to give it a value. Okay, when Java runs that line of code, what's happening is within its memory area, it's going to pick an address. So let's say that we're going to store this variable at spot 91. That's simpler than it actually is, but we'll say that's the way it works. It's going to store the value, the 254, at that address. And along with a name, so I have something to reference that variable with later. Anytime I talk about num in my program, we know we're talking about this memory address here. Okay, lower level programming languages, you don't get this name to use. You have to actually refer the addresses. And in a lot of cases, you'd actually have to specifically assign the address. Java does that for you. And as I create variables, Java is just going to be picking spots in the memory to put them, assign the value, assign the name. Okay, so this is what the basically computer is doing in the background as you're creating variables through your program. All right, so next let's talk about kind of all the little nitty-gritty details that are happening when you make those simple coding statements to create and assign a variable. First thing, let's talk about our identifiers. Okay, an identifier is a name given to variables, classes, or methods. So for example, yesterday we talked about naming a class. We could say we have a triangle class here. Okay, or names for variables. Okay, the main method would be an example of a named method. We have some rules about identifiers. Identifiers should start with letters. They cannot start with numbers. And typically our classes will have capital letters at the beginning, whereas our variables will start with lowercase letters. And in this case here be camel case, where the first word starts with a lowercase letter, then each new word in that variable starts uppercase. Now that's convention. You don't need to follow that, but that's the way the AP test is written. So that's the way we're going to do things in class. And then identifiers can contain letters, numbers, and the symbols $sign or the underscore, and that is it. Okay, you can't have any other like and symbols or percent symbols. Okay, they have to start with a letter, numbers anywhere in there, $sign or number score within the identifier name. All right, we always want to make sure that our variables have meaningful names. They should mean something. So for example, the triangle class, I know that has something to do with triangles. Okay, I know this has something to do with the width of an object or something about being paid. Okay, this is not good code to say I have a double called A or a class called B. You will see examples like that on the AP exam, but for practical coding purposes, give variables a meaningful name. Just gonna make my face disappear here for a second. Then last thing, reserved words cannot be used as identifiers. Okay, so you can't, there's certain names in Java that you can't use, such as int. Okay, int is a variable type. I cannot name a variable int because int is already used. That's going to confuse the compiler. Same thing with double, return, void, boolean, static, long, break, continue. Okay, that's all stuff, reserved words in Java that I don't get to use when I'm naming things. So next thing we're going to talk about are the different kinds of variables we can use in Java. Now in Java, variables are split into basically two categories. There are primitives, which we'll focus on this chapter, and then objects, which we'll start getting into next chapter. But I'm going to say a primitive variable stores a value of a type specified. Okay, and a value, one value. So when I store something as a primitive, it only gets one value. Okay, such as a number, a letter, a true, false. Okay, and in Java, the reason I worry about the type of variable is I'm going to say the type states how much and what kind of data the variable can store. Okay, so with Java, we're going to give the computer a heads up of what type of information it's storing. And then to optimize memory, it's going to find an address in the memory that has that much space available for it. Okay, so for example, a Boolean versus a integer. Okay, Boolean's true or false, 1 or 0, whereas the integer could be a number in the millions. Okay, it's going to give more space for the integer as opposed to the Boolean. Okay, there are a lot of different primitive types. We'll show you those in a minute, but the AP exam, you only need to know how to work with 3 of them. We'll do some things with a few as we go through, but for the AP exam, we have the int type as an integer. Those are whole numbers. The double type, which is our fractions, and then Boolean, which stores true, false values. Okay, here are all the different primitive types in the Java language. Like I said, you don't need to know how to work with all these, just the int, the double, and the Boolean. Okay, but the reason we have multiple, okay, byte, short, int, and long, these are all basically storing integers. And the reason we have different types is, notice here, they all have different ranges of what type of values they can hold. Okay, if I store something as a byte, the biggest number I can store is 127, whereas an int can go up to 2 billion, and a long can get bigger than that. I'm not sure the exact number is. Okay, same idea with float and double. Those are both basically our decimal numbers. Okay, float takes up 32 bits of memory, so that's going to store something that's smaller than a double. The char, as in character, that's going to be something that stores a single letter or a single character on the keyboard at a time. That's something that some Java courses will focus a lot on, not on the AP exam, so we're going to ignore the characters completely. And then Boolean stores 1 bit. Okay, that's just a 1 or a 0, true or false. Like we said, there's not a lot of memory allowed, okay, when you store a Boolean. Okay, so again, let's talk about the integer types to begin with. Okay, integer types can only store integer values, no decimals. And the first line of code here, I have an int. This will be the only one we really need to work with, but I have an int. We'll say its name is 1, and we're going to assign it with this big number right here. That's the biggest number that a Java int can hold. If you try to size something bigger, it'll overflow and not work correctly. And then here I just assign the largest number possible to a short, to a byte, to a long. Again, the reason we have different integer types is for Java to optimize memory usage and only allow enough storage space for what I'm using. Okay, and if I print those, that would just output my different values. So like we said, integers can only store whole numbers. Attempting to assign a fraction or a decimal value to an integer type results in a loss of precision compile time error. In other words, Java will yell at you. This code would not compile. So even if I try to do something like this, int 1 equals 120.0, if you include that point in there, it's not going to work for you. Okay, next up, let's talk about the real number types. I've got a question there because it's a math teacher, that's not quite correct. But basically, we're talking about our numbers with decimals. Okay, real types can store fraction / decimal values as well as the integers. And there's 2 real types, the double and the float. You know, basically, difference between the two is the double can go out to more precision. So I believe it's 15 decimal places. I'm not going to count them out. This will be the one we use throughout class, the double. So if I want to approximate pi, I can do that better with the double as opposed to a float that only goes out to 1, 2, 3, 4, 5, 6 decimal places. Okay, now a double or a float can store integers. So for example, here, if I go double 1 equals 99 and don't give it a decimal place, the computer is going to store that with a 0.0. Java will store that 0.0. And if I printed it, it'd give me the 0.0 here, treating it as a double. And then our last primitive type on the AP exam is the Boolean. Okay, a Boolean type can store true or false only. So in other words, Java is storing a 1 or a 0. So for example, I could say Boolean go equals true. If I print go, then Java is going to print out the word true. Okay, not the word true, but basically a 1 is what it's storing that at. Same idea, Boolean stop equals false. If I printed stop, then you'd print out false. Next up, let's talk about some different kind of ways I can create variables. We're going to talk about the idea of the difference between declaring versus assigning. Okay, so far I've shown you some code where we've both declared the variable. We'd say that on the left side of the equation, a plus is an int variable. That's a declaration of our variable. And then the actual assignment statement is when I have the equal sign here. This is assigning on the right. Okay, so what I've shown you so far is declaring and assigning in the same line of code. A lot of times we'll do that. What I could also do is declare only. I could say int a plus semicolon. What that's telling Java to do is get a space ready in your memory for an int, and we're going to name that space a plus. And then what I could do is assign that later. I could later go back and say a plus equals 56. That's an assignment statement only. You'll see different situations where we want to declare and assign in one step. We'll also have some where we declare it first and then assign it later. And then also, I'm going to say that more than one variable of the same type can be declared and assigned on the same line. So for example, if we are declaring and assigning several ints, rather than having int a plus, int a comp sci on different lines, what I can do is I can say int a plus equals 52, comma, comp sci equals 79. Okay, that's assuming then that both of these are int types, and this will only work as long as I'm doing the same type on the same line. When I print those then, a plus would give me the 52, comp sci give me the 59. Just a little way to save some space and maybe make your code look a little nicer. Okay, then next we'll talk about the idea of a final variable. I'm going to say a final variable can be assigned a value once. So for example here, I've got a double called pi that I want to be 3.14. If I put the final keyword in front of that, okay, so final double pi 3.14, what that's going to do is it's going to make it so my program cannot reassign that double value of pi. Okay, whether it's through user interaction or through coding. Okay, why would I want to do that? Well, you designate a variable final if you do not want it to change after it's been declared and initialized. And typically you're not using final so that the user of your program can't change things. It's mainly so that anybody else working on your code or you working on your code isn't going to be able to change it. So essentially what I'm doing is I'm saying that I have a variable, I never want this to change, and if you try to change it later throughout your program, your compiler is going to yell at you. It's not going to let you do that. Okay, so then I could print out string pi plus pi equals 3.14. Okay, that's a good example. Maybe I want my program to use 3.14 for pi and not change. That'd be an example of using a final that makes sense. Okay, and then the last variable type we'll talk about here is a string. We're not going to get into all the details of strings because it's actually more complicated than you'd think. We'll go through that later. When I say a string type stores groups of characters. So we have the character type. Okay, a string is made up of several characters. And we won't go all the way into this, but I'm going to say a string is an object, not a primitive type, which will have some different results we'll worry about later. Okay, but I can make a string just like I make an int or a double. I'll say string for the type, and notice this is capitalized again because strings are objects, not primitives. So string, I'm going to call my string greeting, and we're going to assign it to hello world. And then if I print that just like we saw a minute ago with combining strings and variables, if I print the string message plus my greeting, okay, I'll get message, the string literal, concatenated with the greeting, which was hello world. That'd be what it print off here. All right, so that's what you need to know about variables to start getting some simple programs off the ground. We'll build on that. Stuff we'll be using all year long, obviously. Okay, so start working on some programs, crank out some code, let us know if you get stuck, and we'll see you folks later here.